Hello and welcome to this online video lecture about types of chemical reactions. By the end of this lecture, you should be able to identify a chemical reaction's type by looking at its equation. So we're going to get right to it with the first type of chemical reactions we're going to talk about. The first type is synthesis. The word synthesis means to make. And so a synthesis reaction takes two separate elements or compounds and combines them together to make one single compound. An example would be if sodium metal reacts with chlorine gas to make sodium chloride. Gotta balance that puppy. There we go. So anytime you see two or more separate elements or compounds combining to form one compound, that's a synthesis reaction. So that one's pretty easy. The next one we'll do is the opposite of synthesis. It's called decomposition. Decomposition is a word you've probably seen before. It means to break down or apart. And so decomposition reactions are the exact opposite of synthesis. You start with a compound, and then through the chemical reaction, it separates into its constituent parts. It's the parts that it's made out of. So if you had a compound made out of A and B, it would separate into A and B. A good example of a decomposition reaction would be like the electrolysis of water. If you take water and you run electricity through it, you can separate it into hydrogen and oxygen gas. So that is a decomposition reaction. The next type of reaction I'd like to talk about is called single replacement. Sometimes you'll see single displacement instead of replacement. Just be aware of that. And this is when one element takes the place of another in a compound. So this pattern would be like if you have element A and you're reacting it with compound XZ, the A would take the A would take the place of either X or Z. So you would get AZ, compound AZ, and then X would be present in its elemental form. Now it could happen either way. You could also have the element reacting with the second compound. Just depends on what the element is. And if that happened, you'd get XA plus Z. So the element can take the place of either one. It depends on what type of element it is. Oops, jeez. An example of a single replacement reaction. A pretty classic one is metal with water. A lot of metals like sodium will react with water and they replace the hydrogen. So you get the metal hydroxide and then hydrogen gas, which of course you have to balance. So the metal is replacing one of the hydrogens, so you get the metal hydroxide and hydrogen gas. Another example of this would be like if you put, say, if you put copper in silver chloride, the copper would take the place of the silver, and you'd get solid silver, elemental silver replaced out of that. The next type of reaction I want to talk about isn't single replacement, it's double replacement. Let me fix that. CEM Oh my goodness, I made it worse. Let's try this again. Replacement. There we go. And this is where elements switch places in compounds. So two elements switch places. So if you had compound AB reacting with compound X, let's do Z, XZ, where A, B, X, and Z are all elements, two of them would switch places. So the A might take the place of the X, and the X would take the place of the A. And so you would get compound X, B, and A, Z. It's called double replacement. These ones are pretty famous for being what are called, or causing a precipitation to happen. Precipitate is when one of the two new compounds that's formed isn't soluble in water, and so it forms a fine solid powder that settles out of the solution. So a really famous one of these that we can't really do anymore because of the toxicity of the metals is when you have lead. I think it's usually lead 2 nitrate. So lead 2 nitrate and potassium iodide. That forms potassium nitrate and lead 2 iodide, which is insoluble and bright yellow. So when you mix these two colorless solutions together, it forms a bright yellow precipitate. It's actually pretty impressive. You might want to Google that, lead nitrate and potassium iodide. I have one final type that you're responsible for this class, and it's the combustion type. This one's a little different. Combustion is basically burning. So it's a reaction of some fuel, we're going to call it X, some compound called X, reacting with oxygen, and it's always going to form carbon dioxide and water. And it might form one or more other products, but it's always going to form those two things. And this is called a combustion reaction. X can be any number of things. It can be like methane, like in our Bunsen burners, CH4. Anytime you burn something, combustion we just call burning. It's a combustion reaction. Now, a lot of students don't realize that anytime you burn something, it actually makes water, but you can easily investigate this for yourself by taking something like a candle and putting a glass upside down over it. You can actually see the water condense inside of the glass, forming on the sides of the glass. But methane reacts with oxygen to make CO2 and H2O. Got to balance this out. So now we need, let's see, a 2 here. And then it's 6 oxygens. So a 3 here. There we go. But anytime you have some compound reacting with oxygen and it makes CO2 and H2O, and there may be other things, but it makes CO2 and H2O for sure, that's a combustion reaction. So those are the types of reactions that you'll be responsible for in this course. Make sure that you can recognize by their equations combustion reactions, double replacement reactions, single replacement reactions, decomposition, and synthesis. Thanks for watching, and as always, if you have questions, please ask in class.